Assume L is a language over alphabet sigma. Assume lambda is the empty string. Now, the question is saying, which of the following statement is or are always true? The question is asking. The question is asking some statements. Okay, so let's solve it. First of all, you tell me, this statement, is this always true? That lambda does not belong to L plus. So you can notice alphabet is given to you. Alphabet is sigma. By definition, alphabet can be empty or not. By definition, alphabet can be empty or not. So this alphabet can never be empty. This is a finite set, finite non-empty set. This is a finite non-empty set. Alphabet can never be empty. This is a finite non-empty set of symbols. Okay, of symbols. For example, you can take alphabet sigma equal to a comma b. This alphabet you can take. Okay, now you tell me, what is the language? Sigma star. What is sigma star? Tell me. Sigma star, you already know. If sigma is a comma b, then what is sigma star? If sigma is your alphabet, then what is sigma star? Sigma star set of all strings. Set of all strings, right? Set of all strings. Tell me what is the language? Tell me what is the language over sigma? What is the language over sigma? What is the definition of that? Means language over sigma. What is that? That is subset of sigma star. That is a subset of sigma star. Every subset of sigma star is a language. So these things you already know. Subset of sigma star. Now you tell me this statement number 1. Is this always true? Lambda does not belong to L plus. Lambda does not belong to L plus. Is this statement always true? So the first statement is saying that lambda does not belong to L plus. First of all, you tell me what is L plus. What is L plus? L plus is L power 1 union L power 2 union L power 3 union L power 4 and so on. Okay, so very simple. This is basically L. This is union of L power I, where I is greater than or equal to 1. Okay, this is your L plus. Now you tell me, can you give me a counter example such that, can you give me a counter example for this statement is false? This statement is false. Can you give me a counter example? Yes, you can easily notice that if I give you, consider this language, lambda, comma, a. Now you tell me, consider this language. Now you tell me what is L plus? For this language, this is your language, lambda, comma, a. Consider this language, or you can consider any. For example, you can consider lambda, comma, double a. Consider this language. Now you tell me what is the L plus. Remember, L plus means L power 1 union L power 2 union L power 3 union L power 4 and so on. This is your L plus. So tell me what L plus will be. In L plus, what you will get? Here you can notice your L power 1. What is that? That is lambda, comma, a. This is your L power 1. What is L power 2? Can anyone tell me what is L power 2? What is L power 2? L power 2 will be, just tell me what is L power 2. L power 2 means L dot L. Remember, L power 2, this is your L. L is lambda, comma, double a. This is your L. Now you tell me what is L power 2. L power 2 means L dot L. Okay, L dot L means lambda, comma, double a dot lambda, comma, double a. Concatenation. So if you do the concatenation, then what will happen? If you do their concatenation, lambda will come. If you do their concatenation, double a will come. If you do their concatenation, double a will come. That is already here. If you do their concatenation, a power 4 will come. So this is your lambda power 2. This is your lambda power 2. So you can notice your lambda power 2 is lambda a square a power 4. Tell me what is lambda power 3. What is this one? Lambda power 3. What that will be? Can anyone tell me? Lambda power 3. You can check it out. This will be lambda a square a power 4 a power 6. You can check it out. Okay, you can do it. You can check it out. This will be lambda a square a power 4 a power 6. You can also do this. L power 4. You can check it out. That will be lambda a square a power 4 a power 6 a power 8. Okay, so you, like this and so on. So tell me ultimately what is L plus. If you do this union, if you do union of L power 1, L power 2, L power 3, L power 4, if you do the union of all these, then ultimately what you will get? You will get lambda a power 2, a power 4, a power 6, a power 8, and so on. So basically you are getting even powers of a. Yes or no? You are getting a power n where n is even. Where n is even. Remember, this you can write as a power 0. Okay, so like this. Is this point clear? Please tell me. Simple, right? So I can say, can you notice that L plus can contain lambda? Yes or no? L plus can contain lambda. L plus can contain lambda. So you can notice this first statement is false. Is this clear? The first statement is false. This is the simple point, that this statement is false. What about the second statement? The second statement is, let me tell you, the second statement is lambda belongs to L plus. Is this statement true? Lambda belongs to L plus. Please tell me, this is your second option. Option number 2, lambda belongs to L plus. Is this statement true? Is this statement always true? No, again, this is false. Let me tell you, this is also false. Lambda belongs to L plus. This is also false. What you can do? You can take this L equal to, consider this language. Consider this language in which you have double A. In this language, you have only one string. So this is your single string language. Here you can notice the cardinality of L is equal to 1. There is only one string in this language. You tell me what is L plus. Tell me what is L plus. L plus means L power 1 union L power 2 union L power 3 union L power 4 and so on. Tell me what is L power 1. L power 1 is A power 2. That is A power 2. L power 4 is A power 4. L power 3 is A power 6. L power 4 is A power 8 and so on. So tell me finally what you got. If you do the union of all of them, what you will get? Do the union. In the union, you will get A power 2, A power 4, A power 6. So you will get A power 2, A power 4, A power 6 and so on. So tell me, you did not get lambda, right? You did not get lambda. So you are basically getting, it's like A power 2n where n is greater than or equal to 1. This is what you are getting. You did not get lambda. Please tell me, lambda belongs to L plus. Is this true? Is this true? Lambda belongs to L plus. This is your L plus. This is L plus. Can I say lambda belongs to L plus? No. So finally, what is the conclusion then? Finally, what you got? See, lambda may belong to L plus. See, if I say lambda belongs to L plus, this is also false. This is the conclusion. Let me tell you the note. Let me tell you the note. Okay, see, lambda belongs to L plus. Is this statement always true? This statement, lambda belongs to always, L plus. This may or may not happen. Yes or no? This may or may not happen. This may or may not happen. So please understand, this may or may not happen. Similarly, lambda does not belong to L plus. What about this one? Lambda does not belong to L plus. Again, this may or may not happen. Again, this may or may not happen. Okay. So remember, it depends on L. Yes or no? Ultimately, I can say it depends on L. It depends on the language. It depends on language L. Okay. Now you tell me one thing. A simple question I'm asking. When can I say that lambda will belong to L plus? This is a very important question I'm asking. When can you say that lambda belongs to L plus? When can I say that lambda belongs to L plus? This is a very important question. Let's answer this question. But before answering this question, let's see the first one. Let's see the note one. What is that? That is that. See, tell me. If lambda belongs to L, then can I say lambda also belongs to L plus? Please tell me. If lambda belongs to L, can I say lambda also belongs to L plus? Please tell me. If lambda belongs to L, then can I say lambda belongs to L plus? This statement is true. Okay, this statement is true because notice proof. Let's see the proof. Let's see the proof. The proof is like this. If L contains lambda, okay, you can have some extra things. If L contains lambda, now what L plus will be? L plus will be L power 1 union L power 2 union L power 3. You will do the union. Now already L power 1 means already you have lambda. Some other strings can be there. So finally, can I say that in L plus also you have lambda? Because you are taking the union. because you are taking the union. We are taking the union. So ultimately I can say that definitely lambda will be there. Okay, this is the proof. Is this proof clear? So if lambda belongs to L, then lambda also belongs to L plus. Now tell me this point. If lambda does not belong to L, if lambda does not belong to L, then can I say lambda does not belong to L plus? If lambda does not belong to L, if lambda does not belong to L, can I say lambda does not belong to L plus? This statement is also true. Please understand, in this L, if you don't have lambda, then can you create lambda in L plus? See, notice, in this L, let's assume you don't have lambda. Let's assume you don't have lambda. These are the strings that you have. Okay, these are some strings, but you don't have lambda. In this L, you don't have lambda. Now tell me, in L plus means L power 1, union L power 2, union L power 3, union L power 4, and so on. So you tell me, here you don't have lambda. There is no lambda here already. Already it is given. There is no lambda here. Can it contain lambda? If L does not contain lambda, if L does not contain lambda, you tell me, if lambda does not belong to L, then lambda does not belong to L square also. Agree? Agree with me? Yes or no? Correct? This statement is true. If lambda does not belong to L, if lambda does not belong to L, then lambda does not belong to L square also. Because in this L, you don't have lambda. You have some strings, but none of them is lambda. W1, W2, W3, none of them is lambda. There is no lambda here. In this, you have no lambda. Okay, so then L square also cannot contain lambda. In L square, what you will have? In L square, you will have, for example, W1, W1, you will have W1, W2, you will have W1, W3, and so on. You will have W2, W2, you will have W2, W3, and so on, something like this. So here also you will not get lambda. Agree with me? Is this point clear? Here also you don't get lambda. Very simple. So if you don't have lambda here, in this, if none of them is lambda, okay, there is no lambda here, then in this situation, L square also does not contain lambda. Very simple. You can check it out. So you tell me, in L square also there is no lambda. In L cube also there will be no lambda. In L power 4 will also there will be no lambda. So ultimately I can say L plus does not contain lambda. So what I can say? I can say lambda does not belong to L plus. Yes or no? Okay. So if lambda does not belong to L, then lambda does not belong to L plus. So finally, which result you got? What is the theorem you got? What is the theorem you got? We have seen two results. We have seen one result that if lambda belongs to L, then lambda also belongs to L plus. The second result we have seen, if lambda does not belong to L, then lambda does not belong to L plus. So you tell me, can I create a if and only if statement from these? Can I create if and only if? Yes, I can say that lambda belongs to L if and only if and only if lambda belongs to L, lambda belongs to L if and only if lambda belongs to L plus. Similarly, I can also say that lambda does not belong to L if and only if lambda does not belong to L plus. So this is what you can say. So your final result, what is that? This is my question. When can I say lambda belongs to L plus? Tell me, when can I say lambda belongs to L plus? This was my question. So what is the answer for this question? If and only if, the answer will be if and only if lambda belongs to L. Okay, is this clear? Lambda belongs to L. If and only if lambda belongs to L. Okay, so very simple. Remember, this statement is correct. Yes or no? Agree with me? This statement is correct. Lambda does not belong to L if and only if lambda does not belong to L plus. Okay, if and only if. Similarly, this statement is also correct, right? If and only if lambda belongs to L, if and only if lambda belongs to L plus. That is the benefit of if and only if. This is the benefit of if and only if. If and only if. Okay, we already know this. We already know that P if and only if Q. This statement is same as P dash if and only if Q bar. Yes or no? This we have already seen in propositional logic. In propositional logic, this is same as P bar. Okay, this is the benefit of if and only if. This we have already seen in the propositional logic. This we have seen in the propositional logic, right? In the propositional logic, we have already seen this. Okay, P, this is the benefit of if and only if statement. P if and only if Q, that is same as P bar if and only if Q bar. These are same statements. This statement, they are same statements. That is the benefit of biconditional statement. This is biconditional. Okay, so P biconditional Q, that is same as P bar biconditional Q bar. Okay, so did you understand the complete analysis so far? So far, did you understand the complete analysis? Understood? So far, what we have done. Now you tell me. Now, okay, now let's see the next. Now let's see next option. See, the next option is, can I say lambda definitely belongs to L star, whatever L you take? Can I say that? Whatever L you take. Is this always true? Yes, this is always true, right? This is always true. Why? What is the reason? What is the reason? Let me tell you the hint. The reason is this, because L power 0 is always equal to this for every L. This happens for every L. For every language L, this happens. Okay, L power 0, that is equal to set containing empty string. Is this empty set? Is this empty set? No, this is not empty set. This is set containing empty string. Remember, this is set containing empty string. Set containing empty string. Okay, so very simple. Now you tell me, this statement is always true. What is the proof? The proof is, what is L star? L star means L power 0, union L power 1, union L power 2, and so on. Now we don't care about the language. This itself will bring empty string. Correct? This will bring empty string. So finally, L star will definitely contain empty string. Okay, this itself will bring empty string. Empty string is denoted by lambda. So this will bring empty string. Okay, very simple. Yes or no? So this is always true. So what can you say about this statement? Lambda belongs to L star. And what can you say about this statement? Lambda does not belong to L star. What can you say about these statements? See, this statement is always true. If this statement is always true, then this statement will be always false. Yes or no? Very simple. Okay, and finally, what can you say about this statement? Lambda belongs to L plus. And what can you say about lambda does not belong to L plus? What can you say about these statements? They may or may not be. They may or may not, depend on the language. They may or may not. May or may not. They depend on the language. Okay, here we depend on the language. Here depends on L. So this is the idea. So this is the conclusion. Now you tell me, one more thing I want to ask. Next, you tell me, if you take any alphabet, now focus on alphabet, whatever alphabet you take. Now you tell me, sigma star contains all the string, right? Sigma star, this is set of all strings. This is set of all strings. So you tell me, can I say, when you say all strings, then it also contains empty string, right? Yes or no? When you say all string, please tell me. When I say all string, it also contains empty string. So you can easily notice. So this sigma star, it contains all strings. Means it also contains empty string. There is all one length string, two length string. So you can notice sigma star that contains 0 length string, 1 length string, 2 length string, 2 length string, 3 length string. Okay, it contains all the strings. So here, can I say that this lambda, can I say this always belongs to sigma star? Can I say? Yes, 0 length string always belongs to sigma star. This will always happen. This will always happen. Okay, very simple. What about sigma plus? If you take sigma, any sigma you take, what about lambda belongs to L plus? Sigma plus, sorry, sigma plus. Lambda belonging to sigma plus. This will never happen. Why? What is the reason? Tell me what is the reason? This will never happen because sigma does not contain empty string, right? Yes or no? Because what is the reason? Because sigma does not contain empty string. Because empty string does not belong to sigma. Okay, empty string does not belong to sigma. So empty string does not belong to sigma plus also. Very simple. Yes or no? In sigma, you don't have empty string. So can you create empty string? In sigma, you don't have empty string. So sigma power 1, sigma power 2, sigma power 3, they don't contain empty string. Because what is sigma plus? Sigma plus means sigma power 1, union sigma power 2, union sigma power 3, and so on. Okay, so this is the idea. Sigma does not contain empty string. Alphabet does not contain empty string. Alphabet never contains empty string. I told you. Okay, empty string never belongs to sigma, never belongs to alphabet. Okay, what is sigma plus? Can anyone tell me? By definition, what is sigma plus? If your alphabet is sigma, what is sigma plus? Sigma plus is set of all non-empty string. Yes or no? That is set of all non-empty strings. Non-empty strings. Yes or no? So you can see, by definition, you can see set of all non-empty strings. So you don't have empty string in sigma plus. Okay, I hope these points are clear. So these are the conclusions I am telling you. With proof, did you understand? Please tell me. I am telling you the conclusion, but did you understand the proof? Proof is important. By chance, if you forget. So these are the things that we have seen. First, we have seen is lambda means this empty string belongs to L if and only if, or I can say this belongs to L plus. Lambda belongs to L plus if and only if lambda belongs to L. This is the one result we have seen. The second result that we have seen, lambda always belongs to L star. This will always happen, right? This will always happen. Okay. Next, third, lambda never belongs to sigma plus. Okay, lambda never belongs to sigma plus. Next, lambda always belongs to sigma star. So all these things we have seen. All these things we have seen, right? Agree? So the proof of all of them we have seen. Very simple. So this is the idea. So remember this point. If lambda belongs to L, it automatically means lambda belongs to L plus. And if lambda belongs to L plus, it automatically means lambda belongs to L. This is the point. Okay, so all the questions, all the options we have seen, the complete analysis we have done. So tell me which options are true, which options are false. Tell me now. Which options true, which options false? Lambda belongs to sigma star, correct. Lambda does not belong to sigma plus, correct. Lambda belongs to L star, correct. So answer will be B, C, D. This will be the answer. The question is asking true statement. So that is the reason answer will be B, C, D. Is this clear? Anyone has any doubt in this complete analysis? Please tell me. So very simple. And this conclusion you can check. This is the conclusion. Okay, you can check. This first result is important. Okay, many students make mistake in this first result. Now let's move on. Now let's see this question. Question number 6 in weekly quiz 24. So tell me. L is a language over alphabet sigma. Sigma is the alphabet. This epsilon denotes empty string. Next, which of the following statement are always true? The question is asking for always true. The question is asking for true statements. So tell me which statement is true statement. We have already seen this. That, tell me what we have seen. This we have already seen. We have already seen that this empty string belongs to L plus if and only if empty string belongs to L. This result we have already seen. Okay. And we have also seen that empty string always belongs to L star. This will always happen. Okay. Empty string always belongs to sigma star. This will always happen. Empty string never belongs to sigma plus. So these results we have already seen. Now you tell me. So we know that sigma star contains empty string. Agree with me? Sigma star will contain empty string. This is your sigma star. and sigma plus will never contain empty string. Sigma plus never contains empty string. Sigma plus. So for example, if your sigma is a comma b, if this is your sigma, then like this. So you tell me, can I say that sigma star is equal to sigma plus union empty string? Can I say that? Please tell me, can I say that? Can I say that sigma star is sigma plus union empty string? Yes, this is correct. Can I also say that sigma plus is equal to sigma star minus empty string? Minus empty string means from sigma star I remove empty string. From sigma star I remove this empty string, I will get sigma plus. Yes, this is also correct. So these are correct. These statements are correct. Okay. Now you tell me, can I say that L star that is equal to L plus union empty string? Is this correct? Is this correct? This statement, is this statement correct? Yes, this statement is true. Why? See, very simple. Because what is L star? What is L star? L star means L power 0, union L power 1, union L power 2, union L power 3, union L power 4, and so on. Tell me what this is. Tell me what this is. L power 1, union L power 2, union L power 3. What this is? This is your L plus. This is your L plus. Correct? And what this is? And what this is? This is your set containing empty string. So yes, this statement is correct, right? This statement is true. Okay, very simple. So very simple, this statement is true. Can I say this statement is true that L plus is equal to, is this statement true? L plus is equal to L star minus lambda. Is this statement true? What about this statement? Is this statement true? This statement may or may not happen. This statement may or may not happen. This statement may or may not happen. Remember, this statement may or may not be true. Means, can I say this statement is true? So I can say, yeah, this statement is basically false, right? I can say this statement is basically false. Can anyone give me a counterexample? Can anyone give me a counterexample for this statement? Yes. If L contains lambda, just notice, if L contains empty string, if L contains empty string, take this example. Take this example. L contains empty string. Take this example. Tell me what is L star? L star will be all the even powers of L, all the even powers of A. Yes or no? L star will be all the even powers of A. What L plus will be for this language? For this language, what will be L plus? L plus also will be same. L plus also will be same. You can check it out. L star, L plus, they are basically same. For this language, L plus, L star, they are same. So what can you say about, can I say L plus is equal to L star minus lambda? Can I say L plus? So this statement is false, right? This statement is a false. Okay, this statement is basically false. Is this clear? See what I want to tell you. Tell me when this will be true. If you remember, we have already seen this. Please understand, we have already seen this, that empty string belongs to L plus if and only if empty string belongs to L. This we have already seen, the proof we have already seen. Okay, now you tell me. Now you tell me. First thing I am asking, if lambda does not belong to L, or okay, let's see, the lambda does not belong to L, then what will happen? Tell me. If lambda does not belong to L, then lambda also does not belong to L plus, right? Then lambda does not belong to L plus. So in this situation, what I can say? In this situation, lambda does not belong to L. If this happens, then lambda does not belong to L plus. In this situation, I can say that L plus is equal to L star minus lambda. Yes or no? In this situation, I can say L plus is equal to L star minus lambda. Now you tell me, the second point you tell me. The second point, if lambda belongs to L, now what? If lambda belongs to L, then lambda belongs to L plus also. Agree? If lambda belongs to L, then lambda belongs to L plus also. So now you tell me, in this situation, can I say this will happen? L plus is equal to L star minus lambda. L star minus lambda. Now in this situation, this will be false. Okay, in this situation, I can say this will not happen. Understood? Please tell me. See, if lambda belongs to L, then lambda belongs to L plus. Lambda belongs to L plus. So can you remove lambda from L star to get L plus? Please tell me. If lambda belongs to L, then lambda also belongs to L plus. So lambda belongs to L plus. So from L star, can you remove lambda to get L plus? I cannot do that. You cannot do that. So finally, what is the conclusion? You tell me. What is the conclusion that you got? You got when this can happen? When this can happen, this will happen if and only if L plus is equal to L star minus lambda. If and only if lambda does not belong to L, right? Yes or no? This will happen if and only if lambda does not belong to L. Is this clear? Please tell me. So this is the complete analysis. All these things, are they clear? So we have seen all these things. So finally, let me give you the conclusion. I hope all the proofs are intuitive. Did you understand all the proofs? So let me give you the conclusion. One conclusion is empty string belongs to L plus if and only if empty string belongs to L. Now from this statement, actually you can find out that this statement also will be true, that L plus is equal to L star minus lambda if and only if lambda does not belong to L. If and only if lambda does not belong to L. Is this clear? Let me know. So this you can do if and only if lambda does not belong to L. Remember, this you can do if and only if lambda does not belong to L. So this is the proof. Now let's see what is the answer for this question then. Sigma star minus empty string is sigma plus. Yes, that is correct. Sigma star is sigma plus union empty string. That is correct. L star is L plus union empty string. That is correct. L star minus empty string. That is not correct. See, okay. So option B will happen if and only if L does not contain empty string. So remember here answer will be what? Answer will be ACD. This will be the answer. Now in the same question, they can play some trick. Let's assume this is also given. That epsilon belongs to is in L. Okay, they give you this. Let's assume they give you this. Now what will be the answer? Tell me. A new question. Now you tell me what will be the answer. In this situation, they already give you that epsilon is in L. Now, so here you can notice that again this is false. Again these statements are true. These statements are always true. Here also again you can notice this statement is false. So in this situation your answer again will be ACD, right? Again your answer will be ACD. But now in the same question, if they say epsilon is not in L, now what will be the answer? Now all statement will be correct. Now answer will be ABCD. This will be your answer. Now the answer will be ABCD. Is this clear? So they can ask you whatever they want. In the GATE exam, they can ask you whatever they want, they can ask. Okay, you can handle it. Can you handle all these variations? L plus, L star, sigma plus, sigma star. Did you understand the difference between all of them?